Welcome back to this quiet corner of the cosmos. Tonight, as the world slows down, we will drift through the hidden history of our planet, exploring forgotten civilizations, buried cities, and the strange cycles of collapse and rebirth that shape humanity's story. Let the calm rhythm of science and mystery help your mind unwind, while the rise and fall of ancient worlds fades gently into the background of your thoughts. If this kind of peaceful journey helps you relax, feel free to like this video and subscribe so you do not miss the next night's exploration. On this restless planet, civilization may not be a single rising story, but a repeating memory that keeps waking up burning bright and then falling silent beneath layers of stone and time. And Earth turns slowly through the dark, carrying continents that look stable and familiar, yet its crust hides scars of impacts, floodplains that once were cities, shorelines that marched inland as the ice melted, and the oceans climbed higher with each passing age. In the soft darkness of night, this world appears calm, its lights glittering like a single continuous network of human presence, but geological strata whisper a different narrative, one where complex societies appear, vanish, and perhaps return in forms that no longer remember their own ancestors. The current civilization looks out into space with telescopes and probes, yet it stands on rock that once lay on ancient seabeds, on flood deposits, on volcanic ash, on sediments that may bury the last echoes of earlier experiments in culture and technology. Each layer records a world that is gone, a climate that no longer exists, a coastline that has shifted hundreds of kilometers, and possibly a pattern of rise and collapse that repeats slowly beyond the short span of recorded history. Archaeology, as it is currently practiced, touches only the thinnest skin of this deeper story, a few tens of thousands of years at most, while anatomically modern humans have walked this planet for hundreds of thousands of years, enough time not for one but for many cycles of complexity to bloom and then crumble. The narrow band called history, filled with familiar names of Egypt, Mesopotamia, Greece, Rome, and later empires, occupies only a small fragment of this expanse, like a brief flare on a very long night. Beneath it lies a far older darkness, where tools and bones are scarce, where coastlines now lie hidden under seawater, and where any architecture built along those vanished shores has long since collapsed, eroded, and been buried beneath sand, mud, and coral. Earth constantly recycles its surface through wind, water, and tectonic drift, so that mountains rise and erode, basins sink and fill, and most traces of delicate structures vanish within a few millions of years, leaving only the heaviest, most stubborn stones behind. In this churning system, even steel, glass, and concrete would not endure indefinitely. They would crack, rust, dissolve, and become part of the sediment until only ambiguous fragments remain to puzzle some future intelligence. That future intelligence might be human again, standing in a later cycle and wondering whether others once reached similar heights, just as the present age wonders whether advanced ancestors walked under different constellations along shorelines that no longer exist. The idea that civilization has begun only once feels comforting because it places the current age at a unique summit, yet the planet itself offers no guarantee that uniqueness is real. It simply hosts whatever experiments emerge from its chemistry and climate at any given epoch. Extinctions and recoveries have already occurred many times among plants and animals, as fossil layers reveal, and each recovery fills ecological niches in new ways while still echoing what came before. In the same way, societies may reinvent familiar solutions to recurring challenges, pyramids for stability and sacred meaning calendars, to track slow cycles in the sky, irrigation systems along floodplains that swell and shrink with the seasons. When similar pressures act on similar minds in similar environments, similar structures may arise even if the previous attempts are forgotten, so that the pattern in stone looks like a memory, even when it is technically a new construction. Still scattered anomalies disturb the tidy timeline like sites that appear older than they should be, astronomical alignments that imply observation over spans longer than any known dynasty, and myths that speak with unsettling clarity about epochs that ended in flood ice or fire. These clues do not yet compose a complete alternative history, but together they suggest that the straight line from cave to city to starship might be an illusion, and that behind the current age stands a longer sequence of rise and reset. From this perspective, modern cities shimmer like the latest layer of a palimpsest, written over earlier inscriptions that have almost but not entirely faded away. Satellites and fiber optic cables may feel new, yet they are just the current expression of a deeper pattern of networking minds and moving information along fragile channels that can break in a single storm or war. If those channels fail, if a global shock arrives with enough force, the present web of knowledge could tear, leaving distant descendants to puzzle over isolated ruins and fragments in the same way that present-day archaeology puzzles over shattered amphorae and broken walls. Earth will keep turning regardless, its atmosphere flowing, its oceans traveling, its crust shifting, while whatever species holds the role of builder tries once again to make sense of the world. In the quiet of the night, this possibility settles over the planet like a second darkness, not terrifying but humbling, as if civilization itself is just one more natural cycle rising from the dust, leaving faint marks, and then returning slowly to silence before the next beginning. In that slow rhythm, the current moment becomes both precious and strangely small, a brief bright phase in a much older and wider pattern that may have pulsed many times before and may pulse again long after the present lights have gone out. On a quiet night, patterns in stone begin to speak not with words, but with angles, alignments, and shapes that repeat across continents and ages. The familiar pyramids on the Giza Plateau stand under slow-turning stars, their flanks rising in clean lines from the desert, each face leaning inward until all meet at a single point that seems to gesture toward the sky. Far across the ocean in the dense lands of Mesoamerica, stepped pyramids rise from jungles and ancient plazas, their terraces stacked like giant stairways, their orientations chosen with care with respect to sunrise, sunset, and the path of celestial bodies. In the river plains of China, pyramid-shaped mounds rest under fields and forests, their forms echoing the same rising geometry. In Sudan, narrow pyramids dot the desert near the Nile, more numerous than those of Egypt, their steep sides leaning sharply toward heaven. One by one, these forms add their voices to a quiet chorus, and a question emerges: why does the same geometry appear again and again, separated by oceans, languages, and eras? The common explanation points to practical simplicity. A pile of stone that must reach upward without collapsing will naturally spread outward at the base, forming a pyramid or cone. Gravity and friction do the design work. Yet the deeper one looks, the more that simple argument begins to fray. Many of these pyramids are not merely piles of rock. Their sides are aligned with notable precision to the cardinal directions, or to specific points on the horizon where the sun or certain stars rise and set at key moments in the year. The Great Pyramid at Giza has its sides aligned to north, southeast, and west with an accuracy measured in a tiny fraction of 1 degree, an achievement that demands careful observation of the sky and a method to transfer those observations into the layout of a vast monument. At Teotihuacan in the highlands of central Mexico, the main avenue and the complex of pyramids are oriented at a specific angle from true north, a choice that appears to encode astronomical cycles and perhaps the rising of particular stars or the passage of special dates. When researchers draw lines through many such alignments, patterns emerge that tie monumental architecture to precession, the slow wobble of Earth on its axis that shifts the stars over cycles of roughly 26,000 years. In some cases, the best fit for the encoded sky does not match the night above the builders, but an earlier sky, as if the designers inherited star maps and traditions from a previous age and felt compelled to honor those older configurations. Ratios within the dimensions of certain pyramids seem to echo simple mathematical relationships. The link between height and perimeter in some structures appears to approximate the circle that would be drawn around them. Whether these echoes are deliberate or the result of practical compromises is still debated, yet they show that builders were comfortable embedding abstract ideas into massive works of stone. Across the world, pyramid complexes often sit within broader landscapes of meaning. Causeways lead toward rivers or toward specific mountain peaks on distant horizons. Some sites reveal layered reuse where newer cultures build atop, beside, or even inside older foundations, preserving the basic geometry, but changing the details of ritual and decoration. It is as if each era finds an earlier footprint and decides to step into it again, reshaping the surface yet keeping the underlying pattern. The stones do not explain themselves. They stand in mute triangles under rain, sand, and snow, their outer layers weathered, their inner chambers sometimes collapsed or emptied. Yet beneath erosion the precision remains. Blocks are laid so closely that a blade could barely slip between them. The orientation of corners and causeways still matches the rising and setting of celestial bodies that move according to the same cycles that guided the hands of long-vanished workers. Each monument becomes a frozen observation, a record of how sky and ground were once linked in the minds of the builders. In a world where written archives burn, rot, or sink beneath floodwaters, such stone records endure for centuries and sometimes for thousands of years, but eventually earthquakes, quarrying, and simple decay erase them as well. The question that drifts through late-night thought is whether these visible pyramids are the first of their kind or only the latest surviving layer of a pattern that extends deeper into a buried past. If former coastlines held earlier generations of monumental architecture now hidden under silt and coral, their geometry would be out of reach, their alignments unknown. Only a few highland or inland structures might remain to hint at a much larger design. The repetition of the pyramid form, the shared fascination with particular regions of the sky, such as the Band of Orion, and the careful linking of tombs, temples, and horizons, all suggest that humanity keeps rediscovering the same language of stone to converse with the heavens. Whether this language was invented independently in each era or whispered forward from cycle to cycle through myths, oral lineages, and half-remembered diagrams is still uncertain. What is clear is that the planet now carries a patchwork of these geometries, some well-studied, others still half-hidden under jungle, desert, or sea. Together they form a kind of planetary memory, an archive carved into bedrock, hinting that the urge to connect heaven and earth through enduring shapes is not a passing fashion of a single age, but a persistent habit that may have accompanied civilization through multiple forgotten beginnings and endings. The megalithic walls rise from hillsides and plateaus like frozen waves, each stone a crest that never falls, locked in place by the weight and precision of its neighbors. In the highlands of the Andes near the ancient city of Cusco, zigzag ramparts show blocks so large that modern observers struggle to imagine them in motion at all. Individual stones weigh as much as several hundred tons, their shapes carved into irregular polygons with many sides, yet they fit together with joints so tight that in some places the gap between them is thinner than a sheet of paper. No mortar holds them. Gravity friction and a deep understanding of contact surfaces are enough to keep them stable through centuries of rain, wind, and earthquakes. When tremors shake the region, it is often the later, more regular masonry that fractures and fails, while the older, seemingly more chaotic blocks remain locked in place, absorbing and dispersing the movement as if the wall itself is a flexible living thing tuned to the rhythm of the ground. Far across mountains and seas on a plateau in the Levant, another set of stones rests under open sky. Here in foundations of an ancient temple complex, blocks of limestone lie arranged in straight courses, 3 of them so vast that each one rivals a ship in size. Their estimated masses reach many hundreds of tons, yet they are cut, moved, and set at a height of several meters above the lower courses. Nearby, even larger blocks remain, partly quarried, still attached to the bedrock, as if the work were abandoned in mid-effort. These stones show crisp edges and carefully dressed faces, their contact surfaces shaped to mesh with neighboring blocks. The marks of tools suggest deliberate planning, not random fracture. In other regions, similar techniques appear. On one Pacific island, statues and wall segments stand against the wind, their bases anchored by stones interlocked in patterns that distribute weight and resist sliding. In parts of the Mediterranean, coastal fortifications display huge blocks with subtle curves and angles that nest into one another. The same principle appears again and again. Rather than simple rectangular bricks laid in even rows, the builders chose large irregular shapes that lock together like pieces of a 3-dimensional puzzle. Modern engineers examining these constructions often note their seismic advantages. A wall made of interlocking polygons can flex and shift slightly during an earthquake without collapsing as forces travel along the varied joints and dissipate. Yet the choice to work in this way demands great skill. Each stone must be envisioned within the hole, its faces carved to match multiple neighbors with a precision that is difficult even with detailed plans and modern cutting tools. To attempt such work with hand tools of stone or soft metal, as conventional timelines suggest, would require time, patience, and a level of organization that strains simple assumptions about ancient labor. The quarrying process itself raises questions. To detach blocks of such scale from bedrock, workers would need to cut deep channels and then apply controlled force to separate the stone without shattering it. Moving the blocks from quarry to site would demand sledges, rollers, prepared roads, or methods now unknown, especially across uneven terrain or upslopes. At the Andean sites, some quarries lie kilometers away and lower in elevation than the finished walls, implying that masses of stone were hauled uphill. In the Levantine example, the largest quarried block remains in a pit, suggesting that even the builders found a limit to what their techniques could achieve. In the present age, when heavy lifting is needed, engineers rely on standardized equipment with known limits. The ancient walls, by contrast, suggest a different kind of confidence, one rooted not in written formulas, but in tradition, repeated experience, or perhaps lost tools and methods not yet fully understood. Some researchers propose that carefully organized labor, simple machines such as levers and ramps, and an abundance of time are enough to explain the structures. Others point to the extreme precision of the joints, the sheer size of the blocks, and the occurrence of similar techniques across distant regions as hints that something more lies behind the stonework. In either case, the result is the same constructions that appear overbuilt, almost excessive, as if designed to endure not just the lifespan of a city or a dynasty, but many cycles of occupation and abandonment. Weather has softened some edges and stained some surfaces, yet the core integrity remains. Vegetation grows in cracks, and along the tops of walls, roots probing for weakness and finding little. Local communities build newer houses against or atop the ancient courses, reusing the old masonry as ready-made foundations. To them, the walls are simply part of the landscape, a given fact rather than a mystery, while outside observers struggle to fit them comfortably into established chronologies. The thought that drifts through the still hours is that such walls might not be the earliest examples of their kind, but the last remaining representatives of a much older tradition. If previous cycles of civilization experimented with stone in similar ways, their constructions may have vanished through erosion, quarrying, and tectonic change, leaving only a few scattered survivors to suggest what once was possible. These surviving walls, with their silent strength and improbable precision, become like fossils of an engineering language that is no longer spoken, a grammar of weight and balance that once shaped cities, now lost beneath soil, sea, or later construction. They stand not just as monuments to the skill of known cultures, but as potential echoes of techniques refined across more than one forgotten age. Above every city ruin and coastline, the sky turns with unhurried certainty, carrying stars that seem eternal on human timescales, yet drift slowly over thousands of years, tracing patterns that careful eyes can follow across generations. Long before printed charts and digital ephemerides, communities watched this turning dome night after night, noting where bright stars rose, where they set, and how the path of the sun, the moon, and the planets shifted along the horizon as seasons rolled past. Over time, the sky became not just a backdrop, but a clock and a library storing information about cycles that far exceed a single lifetime. Constellations rise at certain times of year, guiding planting and harvest migration and ritual. Eclipse patterns repeat in long series, allowing predictions when enough records accumulate. At the deepest level lies precession, the slow wobble of Earth's axis that causes the celestial poles and equinox points to slide along a great circle over roughly 26,000 years, changing which stars mark northeast and the important seasonal thresholds. To recognize precession, a culture must compare sky positions across many centuries. Individual observers live and die while the shift remains subtle, but priests, astronomer families, and temple lineages can notice that a bright star no longer rises exactly where ancestors said it once did. In some traditions, this drift becomes mythic time, encoded as cycles of ages, each ruled by different constellations or divine figures that mirror the changing sky. Temples and monuments seem to bear traces of this long memory. Certain structures in the Nile Valley align not with the current rising of specific stars, but with positions those stars occupied many thousands of years earlier, as if the builders were copying an older template or honoring a remembered configuration. When modern researchers reconstruct the ancient sky using known precessional motion, some alignments make more sense at dates far older than the conventional timelines of the cultures usually associated with the stones. In other parts of the world, rows of standing stones and circular enclosures frame solstice sunrises and sunsets, with remarkable accuracy turning the horizon into a calendar. As centuries pass, precession slowly shifts the exact alignment between stones and rising points, but the original design still reveals that someone once tracked the heavens carefully enough to fix sacred architecture to specific celestial events. In the highlands of an ancient peninsula, carved pillars show animals and symbols that some interpret as star patterns, perhaps a sky story frozen in stone at a moment when the night looked subtly different from today. Far to the west, in lands that would much later carry the calendar stones of Mesoamerica complex, counting systems track cycles of the sun, moon, and Venus with a precision that demands long observation and disciplined record keeping. The numbers in those systems fit remarkably well with actual orbital periods, their errors accumulating only slowly over centuries. For such accuracy to emerge, generations of observers must have watched the dawn and dusk skies, noting the reappearance of a planet, the spacing of eclipses, and the wandering paths of lights that do not behave like fixed stars. Some of these cultures describe time in great cycles, measuring spans of many thousands of years in their sacred counting schemes, as if a sense of deep astronomical history had seeped into myth and ritual. When these disparate traditions are viewed together, an image appears of a planet where multiple societies acquired sky knowledge that stretches beyond the needs of simple agriculture. Tracking precession, for example, does not directly feed crops or guide daily fishing. It reveals itself only through patient long-term comparison of records. Yet precessional cycles appear in the numerology and symbolism of widely separated cultures, hinting that understanding of this slow wobble may have spread along trade routes or survived through hidden custodians in times when much else was lost. The sky acts as a stable reference against which cycles of civilization can be measured. While cities rise and fall, while languages merge and vanish, the stars continue their predictable journeys, and every careful alignment in stone preserves a snapshot of how human minds once linked ground to heaven. If a civilization were to collapse, leaving only a few scattered survivors, their descendants could still look up and notice that certain stones no longer point exactly to the stars they were meant to frame, and with that recognition might come tales of earlier ages when the sky was slightly different. Over very long spans, such stories could become myths of previous worlds, previous suns, or previous humanities, woven around actual memories of changing star patterns. In the present day, the mathematical understanding of precession allows reconstruction of ancient skies, turning monuments into time markers. Some alignments seem to point to dates that precede known settled agriculture, implying either coincidence, misinterpretation, or the possibility that organized observation and perhaps even complex cultures existed earlier than standard histories suggest. A cautious mind notes that patterns can be forced where none were intended, yet the sheer number of sites tied to solstices, equinoxes, key stars, and planetary cycles points to a widespread, deliberate effort to anchor human structures to celestial rhythms. This anchoring gives civilization a way to reach beyond its own expected lifespan. A temple built to catch the first light of the solstice sun will continue to perform its function long after its builders are gone, as long as stones remain upright and the local horizon stays open. In that sense, each observatory stone ring or pyramid becomes a message to the future, stating that at a certain time under a certain sky, someone cared enough to align matter with the motion of the heavens. If cycles of rise and collapse have occurred more than once, then each age may have left such messages, some now completely erased by tectonics and erosion, others partially surviving and folded into the sacred geographies of later peoples who no longer recall the original intent. The quiet idea that lingers is that humanity might be older as an astronomical culture than as a literate one, that star knowledge may have endured through collapses even when writing disappeared, carried by oral specialists who watched the night in every age. Those specialists naming stars, counting months, and noting subtle drifts could form a fragile thread of continuity running through multiple resets, ensuring that when civilization rose again, it did so already holding fragments of a much older conversation with the sky. Across mountains, plains, islands, and coasts, old stories drift through the generations like faint echoes of events too large to remember clearly, yet too important to forget entirely. In village squares, temple courtyards, desert tents, forest clearings, and ocean canoes, elders once spoke of ages before the present age, of worlds that rose, shone brightly, and then ended in water, fire, or darkness. In the Nile Valley, priests told visiting scribes that their land had passed through many cycles, that kingship and knowledge had been granted in times so remote that written lists could describe them only as eras ruled by beings more than human. Farther east, in the land between great rivers, clay tablets carried tales of a lone survivor warned of an oncoming flood that would wash away a corrupted world, a narrative mirrored in other cultures separated by great distances and different languages. On another subcontinent, texts pictured the life of the cosmos as a series of vast ages, rising from purity and slowly descending into confusion before a reset clears the stage for a new beginning. In island chains across seas, myth keepers spoke of previous suns that burned too fiercely or too dimly, ending in catastrophe before the current sky was set in order. These traditions differ in detail, but share a deep structure. They describe a time when understanding and power reach a peak, followed by imbalance, then a catastrophic transition, and finally a smaller group of survivors who inherit a changed world. Often those survivors are guided by culture bearers, figures who preserve fragments of astronomy, agriculture, navigation, or ritual from the destroyed age, and teach them to a more fragile new humanity. From one angle, these tales resemble the tendency to dramatize fear of storms, droughts, and social breakdown, turning them into grand cycles of creation and destruction. Yet some elements remain stubbornly specific. The number of ages, the order of their endings, and recurring references to a vast flood near the close of an ice-bound epoch gather around time frames that modern geology also highlights as periods of rapid change. When researchers examine sea level reconstructions, they find that the end of the last glacial period was not a smooth warming, but a series of sharp steps and pulses. Massive meltwater floods surged into oceans, rearranging shorelines within human lifetimes. A similar pattern appears in the stories. A golden land vanishes beneath rising seas. A proud island city is swallowed in a single violent episode. A bridge of land that once connected now isolated coasts is said to have been broken by waters that climbed until only mountain tops remained. Other myths remember rivers that no longer flow, lakes that vanished, and seasons that shifted so abruptly that familiar food sources failed in a single generation. Each tradition interprets the shock through its own spiritual language, yet they all return to the themes of loss, survival, and partial memory. The survivors in these narratives are rarely blank slates. They carry songs, star lore, planting knowledge, and images of structures that once existed. They may wander in search of new land, founding settlements along rivers or coasts, teaching local populations practices that seem to arrive fully formed. In some cases, legends speak of strangers who appear after a great disaster, bringing with them skills in stone building, irrigation, and timekeeping. Archaeology sometimes finds sudden shifts in material culture that match this pattern, with new architectural styles or agricultural packages appearing abruptly in regions where earlier populations left a different kind of trace. The fit is not exact, but the resonance is difficult to ignore. Another recurring motif is the idea of shrinking ages where each successive world is shorter and more turbulent than the last. This pattern mirrors the experience of communities who look back through fragments of oral history and sense that earlier times were more stable and ordered, even if that perception arises partly from nostalgia. In many myths, time itself seems to quicken as ages roll by toward an eventual reset. Modern readers sometimes wonder whether these mythic ages could encode memories of real environmental phases translated into symbolic form. Records in ice and sediment hint that the climate of the last 100,000 years has swung between extremes, with calmer intervals broken by abrupt events where temperatures shift and ecosystems scramble to adjust. Over long stretches of time, as languages mutate and lineages of storytellers face their own disruptions, detailed records blur into compressed narratives. Many centuries of turmoil can collapse into a single symbolic flood or fire. Survivors may attribute the causes to offended deities or cosmic cycles, rather than to orbital shifts or volcanoes. Yet the sequence of calm, imbalance, catastrophe, and renewal remains recognizable. From this perspective, myths of earlier ages become low-resolution historical images preserving the outline of events while losing fine detail. They do not tell a precise chronology, but they may carry enough structure to hint that civilization has passed through several high points before the current one. Perhaps most intriguing is the way these stories insist that knowledge once gained is never entirely lost. Even when whole worlds drown or burn, someone remembers how to read the sky, how to sow crops at the right time, how to align structures to solstices and equinoxes, and how to speak of distant epochs with the sense that they were more than imagination. That insistence suggests a dim awareness carried from fireside to fireside that the present is only the latest chapter in a much older saga, and that beneath everyday life lies a buried continuity linking multiple cycles of rise and fall into a single mysterious story of a species that keeps rebuilding itself from the edges of its own disasters. In the long quiet of geological time, the planet usually changes with slow patience, yet sometimes this rhythm breaks and the world pivots abruptly into a new state. Among these sharp turns, the sudden cold spell known as the Younger Dryas stands out across the end of the last ice age. For thousands of years after the peak of the glacial period, ice sheets had been retreating, seas had been rising, and climates in many regions had been growing milder. Then, in a geological instant, the trend reversed. Temperatures in parts of the northern hemisphere dropped, glaciers stopped shrinking, and in some places advanced again, and ecosystems that had been adapting to warmth were thrust back into near glacial conditions. In layered sediments, this transition appears as a thin boundary, a change in pollen grains, dust, and chemical signals that marks a return to cold and dry environments. For many years, the cause of this event puzzled researchers. Some proposed that a flood of fresh water from melting ice had poured into the North Atlantic, disrupting ocean circulation and cutting off warmth to northern lands. Others looked to more distant triggers. As more cores were drawn from lake beds, ice sheets, and ancient soils, a pattern of clues emerged. At the onset of the Younger Dryas, some layers show elevated levels of rare elements, tiny spherules of glassy material and microscopic diamonds that form under intense heat and pressure. Charcoal spikes suggest continent-scale wildfires, as if vast stretches of vegetation had ignited almost at once. From these hints, a hypothesis arose that fragments of a disintegrating comet or asteroid swarm had entered the atmosphere and exploded over polar and mid-latitude regions, raining down energy across broad areas of the northern hemisphere. In this scenario, the sky itself becomes an agent of reset. Objects arriving from the outer reaches of the solar system carry enormous kinetic energy. As they strike the atmosphere at many kilometers per second, they compress air, generate shock waves, and release heat that can ignite forests and grasslands. Dust, soot, and vapor plume into the upper air, dimming sunlight and altering climate. If some fragments reach ice sheets or ocean surfaces, they can trigger rapid melting or disturbances in circulation that amplify the initial shock. Whether through impact, meltwater, or a combination of causes, the Younger Dryas lasted for more than 1,000 years, a long chill that reshaped landscapes and challenged every living thing. Large mammals that had thrived along the edges of the retreating ice, such as mammoths and giant ground sloths, disappear from the fossil record in many regions shortly after this transition. Human cultures that had been hunting these animals and exploring newly opened lands suddenly faced a harsher world with changing resources. Some groups vanish from the archaeological record. Others shift technologies, food sources, and settlement patterns, adapting to a colder, less predictable climate. Along ancient shorelines where meltwater pulses and rising seas repeatedly redrew the coast, any camps, villages, or early structures would have been at risk from storm surges and floods. Wooden posts, woven walls, and simple stone foundations do not fare well under repeated inundation and shifting sediments. Over thousands of years, coastal plains that once lay above sea level sank beneath the waves, carrying with them whatever traces might have remained of human activity. If communities had begun to experiment with denser settlements or early forms of monumental building along those coasts before the Younger Dryas shock, their legacy would now lie buried under sand, silt, and marine life. Only hints might remain on higher ground in inland sites that seem advanced for their age, or in myths that speak of a lost temperate world destroyed by a return of cold and flood. From the vantage point of the present, the Younger Dryas functions as a reminder that the end of the Ice Age was not a smooth slide into the stable warmth of the current epoch, but a jagged climb with sudden drops. For any human cultures living through that swing, the experience would have been profound. Memories of softer times would pass to younger generations as distant tales and rituals and stories might grow around the turning in coding advice about where to live and which signs in the sky or the behavior of animals might presage another abrupt change. If a cosmic impact did play a role, bright streaks in the heavens, thunder without storms, and nights lit by distant fire would have carved themselves into terrified memory, easily transformed into tales of angry gods or burning serpents across the sky. Even without direct human records, the planet carries signatures of such events in ice bubbles, mineral grains, and charred residues, like a diary written in elements rather than in words. When these signatures are compared to the timelines of human presence, they show that anatomically modern humans have already lived through at least one global climate whiplash of remarkable speed and scale. If a civilization more complex than currently acknowledged had been growing along late glacial coasts, that shock could have cut it down close to the root, leaving only scattered survivors in refuges of relative stability. Those survivors forced to rebuild in a changed world might preserve fragments of their former knowledge in starlore stoneworking or ritual calendars while their material achievements eroded away. The sudden freeze and the possible falling fire thus stand in this story as a model of how a planetary reset can occur without extinguishing the species itself, resetting not biology but complexity, erasing much while leaving enough life for the cycle to begin again. Beneath the thin shell of continents and seas, Earth carries hidden oceans of heat. Slow currents of molten rock rise and sink in the mantle-feeding strings of ordinary volcanoes that mark plate edges and island arcs. These vents can be dramatic and deadly on human scales, yet in the deeper rhythm of the planet they are modest like small leaks in a pressurized system. Far more rare and far more disruptive are the vast caldera systems often called supervolcanoes. Here, over tens of thousands of years, magma collects in broad reservoirs, its chemistry changing as crystals grow and settle, gases concentrate, and pressure builds under roofs of thick, brittle crust. Most of the time, that crust holds, flexing slightly as the chamber swells and contracts. From the surface, this motion may appear only as gentle uplift hot springs and scattered earthquakes. For long ages, forests grow, lakes form, and animals wander across country that is in reality the thin lid of an immense furnace. When such a system fails in a major way, the change is sudden. Instead of a single mountain venting in a narrow plume, an entire region can fracture. Ash gas and pulverized rock surge into the sky while pyroclastic flows, mixtures of searing gas and debris, race outward at hundreds of kilometers per hour. As the chamber empties, the roof collapses inward, leaving a broad sunken basin that later may fill with water or volcanic plains. The eruption of the Toba caldera on an island in what is now Indonesia stands as one of the largest known explosions of this kind. Rock layers and ash deposits show that an enormous volume of material was blasted out in a single episode, coating much of southern Asia in ash and leaving a distinctive marker in distant ocean sediments. After the blast, sulfur-rich aerosols in the upper atmosphere would have reflected sunlight back into space, dimming the sky and cooling the surface. Climate records suggest that global temperatures fell and stayed low for several years, a volcanic winter layered on top of the already unstable conditions at the end of the last ice age. In such a world, growing seasons shorten, monsoon patterns falter, and ecosystems scramble to adjust. Large animals already stressed by shifting habitats can vanish from whole regions. Human groups that depended on predictable plants and herds suddenly find their food sources unreliable. Archaeological traces hint at cultural changes and local abandonments around this time, while genetic studies of modern humans show signs of a sharp reduction in ancestral population, as if only a relatively small number of lineages survived to repopulate the world. Whether Toba alone caused that bottleneck, or merely contributed to a cluster of stresses, it offers a clear example of how a single geological event can reshape the conditions for life over an entire planet. If an advanced civilization had been present then with cities, ships, and complex networks of trade, its vulnerability would have been even greater. Ash can collapse roofs, clog rivers, and make air dangerous to breathe over areas far from the source. Darkness and cold can ruin harvests for several years in a row, turning surplus into shortage and shortage into famine. In such conditions, the reach of central authorities shrinks. Remote settlements are cut off, roads and ports become difficult to use. Knowledge that depends on large coordinated projects such as fine metallurgy, monumental architecture, or long-distance navigation loses its support structures. Within a few generations, stories of a brighter age before the ash may persist only as legends of lost cities, angry mountains, and a sun that once grew weak behind a pale veil. Supervolcanoes are not relics of a vanished Earth. Several active caldera systems lie beneath modern landscapes, their outlines traced by careful studies of ground motion, heat flow, and earthquake patterns. On a high plateau in North America, one such system has erupted in colossal fashion multiple times over the past few million years, each event blanketing wide regions in volcanic deposits and reshaping ecosystems. Today, tourists walk among geysers and hot springs there, while instruments record the slow heave and sigh of the crust above the hidden reservoir. On human timescales, the region feels almost timeless, yet the rock record shows that its quiet phases are only intervals between rare, overwhelming outbursts. In a world like the present, dense with cities, farms, power lines, fiber cables, and aircraft, a future super-eruption would send shock waves through systems that depend on precision and continuity. High-altitude ash plumes could circle the globe, darkening skies, grounding flights, and interfering with satellites. Cooler summers and altered rainfall could test the resilience of agriculture that relies on narrow climate bands and long supply chains. In such a scenario, the direct footprint of the eruption would be only the beginning. Economic networks could fracture, information infrastructures could fragment, and political arrangements could strain under the pressure of simultaneous crises. For a civilization built on the assumption of gradual change, the sudden arrival of a multi-year volcanic winter would feel like a rupture in the basic rules of reality. In deeper geological time, even larger volcanic events have poured sheets of lava across continents and released gases for tens of thousands of years, contributing to past mass extinctions. Against that backdrop, the present epoch appears as a relatively calm chapter in a much more turbulent volume. From the perspective of cycles of civilization, every supervolcano represents a potential reset point, a hidden lever that can push complex societies back towards simpler forms. Along the edges of every continent, the sea hides a drowned archive. Maps show coastlines as clean borders between blue and green, but in the recent geological past, those borders wander back and forth across the shelves like slow, restless tides of stone. During the height of the last great glaciation, so much water lay locked in ice that global sea level stood more than 100 meters lower than in the present age. Broad plains stretched outward from what are now cliffs and crowded beaches, turning many shallow seas into exposed grasslands, river valleys, and marshes. Herds of animals moved across these spaces, following rivers that now flow invisibly along the seabed. Human groups drawn by abundant resources where land and water met settled along these ancient coasts, building camps, villages, and perhaps early towns at river mouths and sheltered bays. In that colder world, the true centers of human activity likely lay on land that no longer exists above the waves. As the ice sheets thinned and retreated, meltwater poured into the oceans and the sea began a long, uneven climb up the continental slopes. For many thousands of years, shorelines marched inland at a pace slow enough for communities to adapt shifting settlements uphill and abandoning old camps as new beaches formed. Yet this rise did not proceed as a gentle, constant slope. At intervals, immense ice dams burst, releasing lakes in sudden pulses that sped the climb and sent walls of water surging into coastal basins. In some regions, entire lowlands vanished within the memory span of a few generations. In the northern Atlantic, evidence reveals a gigantic submarine landslide along a submerged escarpment. When that mass of sediment failed, it sent a train of waves racing outward, a mega tsunami that slammed into nearby coasts with heights that may have rivaled tall buildings. On plains that once connected islands and mainlands, shallow communities would have seen the ocean withdraw and then return as a roaring wall of white water, flattening forests, sweeping away animals, and erasing any fragile structures. What had been a habitable bridge between lands became a seafloor, its rivers drowned, its hills transformed into shoals and banks. Farther south and east, other coasts tell quieter versions of the same story. Divers find ancient river channels carved into submerged plateaus, their banks lined with buried sediments that contain tools and bones. In warm waters off certain peninsulas and islands, stepped formations rise from the seabed like the ghosts of plazas and stairways. Some researchers argue that they are natural jointed rocks shaped by waves and currents, while others see in their angles and proportions the faint outline of human modification. Regardless of interpretation, the presence of such features at depths that match lower ancient sea levels highlights how much former shoreline topography now lies out of easy reach. In shallow bays near the mouths of great rivers on another subcontinent, explorers have mapped structures that resemble walls and temple bases beneath layers of mud. Pottery fragments, worked stones, and other artifacts suggest that dense settlements once stood there when the sea lay many kilometers farther out. Over time, as estuaries widened and tides intruded, those towns succumbed to erosion and flooding, their remains entombed under silt carried by the same rivers that once nourished them. On a larger scale, entire cultural heartlands may have existed on now drowned shelves. In northern seas, a land that once connected islands, now separated by channels, is reconstructed through sediment cores and animal fossils. This region, laced with rivers and lakes, would have offered rich hunting grounds and fertile soils. It persisted for thousands of years before the rising ocean finally breached its lowest points and transformed it into a patchwork of shrinking islands. Communities living there would have watched familiar hills become peninsulas, then isolated peaks, and finally shoals that vanished below the waves. Such experiences could easily crystallize into enduring tales of a green country taken by the sea, remembered long after the exact geography faded. When modern observers consider the possibility of earlier cycles of civilization, the drowning of coasts poses a profound challenge. If complex societies are drawn to shorelines for trade, food, and travel, then a large fraction of their infrastructure would stand on ground now submerged. Harbors, canals, markets, shipyards, and ceremonial centers, built of wood, earth, and modest stone, would leave only subtle traces after millennia under shifting sediments and marine life. Even more robust structures could collapse under earthquakes and storms, breaking into fields of rubble that are difficult to distinguish from natural outcrops without detailed surveys. Most underwater regions have never been mapped at the fine resolution required to recognize artificial remains. The few that have been studied often lie near modern ports or resource deposits, leaving wide stretches of ancient shelf as blank spaces on archaeological maps. In this context, each known submerged site, whether clearly human-made or merely suggestive, takes on outsized importance. It shows that human architecture does indeed sync with sinking land, and that traces of past coastal cultures can survive where conditions are favorable. It also hints that much more may lie hidden beyond current detection. The present age, with its sonar submersibles and remote sensing, is only beginning to read this drowned archive. For those seeking signs of earlier cycles of civilization, the ocean becomes not just a barrier but a veil covering what may once have been the busiest regions of the planet. The land that carries visible ruins today might represent only the upper inland fringes of older worlds whose true centers remain silent beneath cold, dark water. Visible history holds its own small apocalypses episodes where complex societies crumble not in distant mythic ages, but within the span of a few lifetimes, leaving behind familiarity and ruin. In the humid forests and limestone plains of the Maya lowlands, stone cities once rise along causeways, their towers and pyramids painted in bright colors that catch the sun. Observatories track the motions of planets, and the cycles of Venus scribes record dynastic histories in glyphs, and rulers coordinate labor to build reservoirs, terraces, and ceremonial plazas. For centuries, this network of city-states expands, competes, and flourishes. Then, in what the archaeological record shows as a compressed sequence of centuries, the system falters. Construction slows, monuments are left unfinished, inscriptions dwindle, and many urban centers are abandoned. Populations shift, trade routes thin, and the forest slowly reclaims plazas that once echo with ritual and commerce. The reasons appear multiple and intertwined. Pollen records and lake cores indicate episodes of drought, with rains failing or arriving in unpredictable patterns. Deforestation and soil exhaustion may make agriculture more fragile just as climatic stress increases. Political rivalries and warfare intensify, further destabilizing already strained systems. Collapse does not arrive in a single night of catastrophe, but in cascading failures that from the vantage point of a few centuries later look like a sudden disappearance. Far to the north and east, another decline unfolds around the Mediterranean. The Western Roman world once linked cities through roads, aqueducts, and legal frameworks that extend from cold northern rivers to hot desert frontiers. Grain flows from distant provinces to feed dense urban populations, and knowledge travels along the same routes as traders and officials. Public baths, forums, libraries, and theaters express a shared architectural language, yet beneath this apparent stability, tensions build, economic inequality grows, governance becomes more complex and often less effective, and external pressures from migrating and invading groups increase. Epidemics sweep through crowded settlements, weakening populations and eroding confidence. In the space of a few generations, territories that had been tightly integrated fracture. Central authority retreats, long-distance trade diminishes, and many urban centers shrink or empty. In former Roman lands, people still build, farm, and worship, but the scale and sophistication of the earlier network fade. Roads fall into disrepair, some aqueducts break and are not fixed, and literacy declines. To later observers, this sequence appears as a civilizational reset, a descent from imperial-scale complexity into a more local, fragmented world. Even more mysterious is the earlier breakdown now called the Bronze Age collapse. Around the eastern Mediterranean and Near East, a web of kingdoms, city-states, and empires once exchanges metals, grain, textiles, and ideas. Clay tablets and inscriptions name rulers in many lands, record treaties and trade agreements, and tell of diplomatic marriages between courts separated by seas. Then over roughly a century or two, many of these polities fall. Cities burn, writing systems vanish from everyday use, and skilled crafts decline. The causes remain debated. Climate reconstructions point to a period of drought and cooling. Earthquake storms may damage coastal infrastructures. Groups described as sea peoples attack from the water. Internal rebellions and shifting alliances likely compound the chaos. Again, the pattern is not a single cause, but a convergence of stresses that exceed the resilience of existing systems. Once key nodes fall, the rest of the network unravels. These visible collapses share features that illuminate how a complex civilization can move from apparent strength to fragmentation. Each relies on long-distance specialization where cities and regions produce specific goods and depend on trade to obtain others. Each develops bureaucratic and ritual structures that require steady flows of resources to function. Each alters its environment, sometimes pushing agriculture into marginal areas or cutting forests faster than they can regrow. When external shocks arrive in the form of drought, invasion, or disease, these internal vulnerabilities amplify the impact. Feedback loops turn local shortages into widespread crises. Trust in central institutions declines, making coordinated responses harder. Communities retreat to smaller, more defendable, or more fertile regions, abandoning large public works they no longer have the means or incentive to maintain. For later ages, the ruins of these societies offer both warning and explanation. The stones show that humans reach high levels of organization and artistic expression more than once. They also show that such heights are not permanent. A city can stand for many centuries, outlasting dynasties and fashions, yet still fall into silence once certain thresholds are crossed. Paths through once busy forums sprout grass. Roofs collapse, leaving only foundations and fragments for future archaeologists to puzzle over. If cycles of civilization extend deeper into time than the written record, then these collapses may serve as models of much older resets. They demonstrate that complex systems can fail without total biological extinction, leaving survivors to carry fragments of memory into whatever comes next. They also illustrate how quickly knowledge can shrink. After the Western Roman collapse, skills in making certain kinds of concrete, in maintaining large-scale infrastructures, and in copying entire libraries of technical and philosophical texts diminish or disappear in parts of Europe. Centuries later, those lands reinvent some of these capacities, yet for a long interval, the level of integration and expertise remains lower. In the quiet of night, the record of these declines suggests that civilization is not a steady climb, but a serrated line rising and falling with each peak feeling final to those who stand upon it. The broken stones and scattered inscriptions left behind become testimony that complex worlds can evaporate in short spans, leaving future ages to wonder how many times this pattern has played out before. In the long shadow of collapse, when monuments crack and roads fall silent, a different kind of architecture carries the weight of continuity. It is built not of stone, but of memory preserved inside human minds and passed from voice to voice along fragile chains of teaching. In every known age, there are people whose lives revolve around keeping stories, formulas, maps, and rituals alive when material structures and political orders falter. They become walking libraries for cultures that can no longer rely on steady supplies of ink paper or stone carvers. After major disruptions, these keepers of fading memory often travel following trade remnants, refugee flows, and pilgrimage paths, stitching broken regions together with narrative threads. In coastal communities that watch the sea advance, elders tell of former shorelines of fields and villages that now lie beneath the waves. Their tales include details about currents, submerged rocks, and old river mouths that remain useful long after the land is gone. On islands where storms have stripped soil, local navigators memorize wave patterns and star risings, preserving charts in song and story rather than on fragile maps. In highland valleys shaken by war or drought, specialist lineages hold genealogies, legal codes, and ritual sequences, reciting them at ceremonies that serve as both social glue and training ground for the next generation of memory bearers. Among such groups, failure to learn is not merely a personal loss. It threatens the survival of accumulated experience that may stretch back through many forgotten political arrangements. In some ancient societies, classes of priests and scholars devote themselves to tracking celestial cycles, festival dates, and agricultural timing. Even when central temples fall, individuals trained in this sky lore can carry fragments into new settlements, adjusting practices to fit different horizons while preserving core techniques. The same is true of healers who know where medicinal plants grow, of metallurgists who remember combinations of ores and temperatures needed to produce reliable tools, and of builders who have internalized proportions and methods for stable walls and roofs. When written scripts vanish or become restricted to a tiny elite, these practical lineages often hold more continuity than surviving archives, weaving knowledge directly into habits and craft traditions. In the historical record, glimpses of such continuity appear in unexpected places. Some island cultures preserve star names and navigational chants that encode positions between landfalls separated by many hundreds of kilometers, demonstrating that oral transmission can maintain complex spatial information across centuries. In remote interior regions, ritual calendars align with solstices, equinoxes, and lunar cycles, even when communities have no written almanacs, hinting at old sky-watching traditions carried through turmoil. Accounts of early travelers describe wise people who, though living in modest conditions, recite long lists of kings' battles and migrations that reach farther back than any existing monument in their area. These human archives become especially important after deliberate destruction of formal knowledge stores. When invaders burn libraries or conquerors outlaw certain teachings, some custodians hide fragments in coded stories, weaving technical material into myths that appear harmless to outside rulers. Over time, the protective shell outlives its original purpose, leaving later generations with tales whose symbolic layer remains clear, while their encoded practical content is only partly understood. In several traditions, for example, flood myths include advice about where to build and where not to build, and which signs in animal behavior or in the sky should prompt relocation. These details suggest that survivors of earlier calamities attempted to package hard-won lessons inside narratives compelling enough to be repeated for many generations. As cycles of rise and fall accumulate, the burden on memory keepers grows. They no longer preserve only one age's experiences, but a layered palimpsest of insights, warnings, and patterns. Some of this content inevitably slips away each time a lineage is disrupted by war, epidemic, or forced displacement. Still, a core often persists, especially when tied to regular practice. Rituals repeated annually, star observations performed nightly, and construction methods used in many houses anchor knowledge more firmly than teachings confined to rare occasions. From the perspective of deep time, it is possible that such lineages form a thread stretching beyond written history, carrying fragments of pre-collapse sciences and cosmologies into later religious and philosophical systems. Even when original meanings blur, certain obsessions remain precise orientation toward cardinal directions, careful tracking of long astronomical cycles, reverence for specific mountains and springs that once served as reference points or safe refuges. In a present world saturated with digital storage, the role of embodied memory might seem diminished, yet the underlying principle remains. Complex societies rely on small groups of people who understand how crucial systems work, from power grids and communication networks to vaccine production and satellite navigation. Manuals exist, but in practice it is experienced technicians and organizers who hold the living version of the knowledge. If a severe disruption were to remove a substantial share of these specialists, large technological capabilities could vanish in a single generation, leaving survivors surrounded by artifacts they cannot repair or replicate. Seen against both documented and speculative cycles, the keepers of fading memory emerge as central figures in the story of civilization's resets. They do not appear on grand monuments that celebrate rulers and battles, but they shape what rises after each fall, determining which pieces of the old world seed the new and which become rumors of ancient wonders. In the stillness of night, the image of these human bridges between ages suggests that continuity is not a property of empires or devices, but of minds trained to remember through chaos, carrying flames of understanding across the dark intervals between bright phases of civilization. The record of ancient tools and artifacts usually follows a measured curve from simple stones and bones to metals, wheels, and intricate works of art. Yet scattered along this curve are objects and techniques that seem to rise above their context like sudden peaks on an otherwise gentle landscape. These machines and materials out of their expected time are not proof of lost empires by themselves, but they stir a quiet unease in the story of a smoothly advancing civilization. In the remains of a shipwreck off a rocky coast in the Mediterranean, corroded fragments of bronze once lay in storage, their gears and plates fused together by centuries beneath salt water. When modern imaging peered inside a lattice of interlocking wheels, emerged each tooth cut with care, each axis set to turn in coordination with others. Reconstructed, this device behaves as a compact mechanical model of the sky, able to track the positions of the sun and moon, predict eclipses, and mark cycles of ancient games and calendars. Its level of sophistication rivals that of clocks built many centuries later in another age, yet no other known mechanism of similar complexity survives from its own period, and written descriptions of such technology are scarce. It stands almost alone, like a single surviving page from a vanished technical library. In another region, small clay jars with metal inserts have been interpreted by some as primitive electrochemical cells capable of producing a faint electric potential when filled with acidic liquids. Experiments show that such arrangements can plate thin layers of metal onto other surfaces, hinting that craftspeople might have discovered ways to harness hidden forces in liquids long before formal theories of electricity. Whether these jars truly served as batteries or held some other function, their design leaves room for speculation about lost branches of experimentation. Moving from small devices to great stones, the precision found in certain ancient constructions continues to puzzle modern observers. At a high plateau in the Andes, blocks of hard volcanic rock are carved into shapes so regular that their faces meet at nearly perfect right angles, with surfaces smoothed to a degree that suggests the use of advanced abrasives or methods not yet fully reconstructed. Holes drilled into these stones maintain consistent diameters along their depth, and grooves are cut with a regularity that invites comparison to machine work. Similar impressions arise in the interior of some monumental tombs, where sarcophagi and inner chambers display flatness and squareness that approach modern engineering tolerances, even though conventional accounts ascribe their creation to tools of copper and stone guided by cords. In the realm of metal, a slender pillar of mostly pure iron stands exposed to monsoon rains and city air, yet shows remarkably little corrosion after many centuries. Its composition and the microstructure of its surface reveal a stable protective layer that formed through a combination of forging technique and environment. Craftspeople who produced it did not leave detailed manuals, yet they arrived at a recipe that later metallurgy took a long time to understand. Elsewhere, blades forged in a particular tradition earned a reputation for unusual hardness and flexibility, able to hold sharp edges and withstand repeated stress. Microscopic study of surviving examples shows intricate patterns within the steel, including structures at scales unimaginably small to smiths who worked by eye and feel alone. The knowledge of how to consistently produce such material eventually faded, lost amid shifting trade routes and political changes. These examples represent only a portion of a wider pattern. Here and there, archaeology uncovers lenses of clear stone ground with skill-colored glazes whose recipes depend on careful balances of temperature and chemistry, or pigments that resist fading with a stubbornness rivaling many modern dyes. In some ancient theaters, sound carries from stage to distant seats with a clarity that suggests deliberate acoustic tuning. At certain ceremonial sites, standing in specific spots produces echoes and effects that seem intentionally designed, as if builders understood how to sculpt not only stone but the behavior of air and vibration around it. Alone, each of these achievements can be explained as the result of trial and error, guided by craft traditions and keen observation. Together, they suggest that earlier ages reached local peaks of technical understanding, more than once peaks that were not always preserved or widely spread before disruptions arrived. In a civilization vulnerable to fire, war, and sudden environmental shocks, many such peaks would be sharp but narrow, rising briefly above the surrounding plateau, and then disappearing when the communities that supported them dissolved. Without mass printing or robust archiving, knowledge concentrated in workshops and households can vanish when a single city burns or a lineage fails to train successors. The notion of machines and materials out of their expected time thus fits naturally into the larger idea of repeated resets. Each cycle may climb its own slopes of ingenuity, discovering solutions to practical problems and glimpsing patterns in nature. Some of those discoveries may parallel or even surpass those of later eras in specific niches while lagging behind in others. When collapse comes, isolated achievements shatter along with the broader system that sustains them, leaving only durable remnants buried in wrecks, foundations, and ruins. Future ages digging into the ground find these remnants without their surrounding context and struggle to place them on the timeline of progress they expect. In the quiet hours, the scattered presence of such artifacts hints that civilization's path is less a smooth ramp and more a jagged ridgeline where similar heights are reached repeatedly under different skies, remembered imperfectly and recorded only in the most resilient materials that chance allows to survive. The planet drifts through space, wrapped in air and magnetism, circling a restless star, while the wider galaxy wheels slowly around its own distant center. On human scales, the sky seems steady, yet over longer spans, the environment through which Earth travels changes in quiet but profound ways. The orbit around the star stretches and tilts in subtle cycles. Sometimes the path becomes slightly more elongated, sometimes less. Sometimes the axis leans a little farther, sometimes a little closer to upright. These orbital patterns unfold over tens of thousands and hundreds of thousands of years, gently modulating how sunlight falls on different latitudes. Ice sheets grow and retreat in response, deserts expand and contract, and sea levels rise and fall as frozen water moves on and off the continents. In this rhythm, climates that seem natural and permanent for a few thousand years are revealed as temporary chapters in a much longer story. Layered on these orbital dances is the behavior of the star itself. It pulses through cycles of activity, its surface spotted and flaring in patterns that last about 11 years and also in longer, less regular swings. When the star's magnetic fields twist into violent forms, streams of energetic particles race outward. Most of the time, Earth's own magnetic shield catches these flows, funneling them toward the poles and turning them into shimmering auroras. However, at times, the star releases storms far stronger than those recorded in recent centuries, hurling vast clouds of charged particles across space. If such a storm struck a planet without electronic technology, it would produce strange lights and perhaps disturb animals that rely on magnetic senses, but its wider impact would be limited. In an age dense with power lines, satellites, and delicate circuits, the same storm could overload transformers, disrupt navigation, and black out entire regions. Tree rings and ice cores preserve traces of past solar outbursts that exceed anything measured directly in the modern era, suggesting that the present quiet may not represent the full range of possibilities. Beneath these influences lies the deeper behavior of Earth's magnetic field itself. Generated by flows of molten metal in the outer core, this field is not fixed. It wanders, weakens, and strengthens over time. On occasion, the poles drift so far and the field becomes so disordered that a full reversal occurs with magnetic north and south trading places. The rock record shows many such flips separated by irregular intervals of hundreds of thousands of years on average. During the transition, the field can weaken dramatically, reducing the shielding against cosmic rays and solar particles. Increased radiation at the top of the atmosphere may alter chemistry, affect climate in subtle ways, and raise the background rate of genetic change. For small local societies, such variations may pass unnoticed beyond brighter auroras and small shifts in environmental patterns. For a global technological civilization that wraps the planet in conductive infrastructure and orbits metal shells full of electronics overhead, A weakened field coinciding with a major solar storm could prove far more disruptive, damaging satellites, interfering with radio links and stressing power networks in ways that few systems are presently designed to handle. Beyond the star and field lies the rest of the solar system, a swarm of rocks and ice ranging from tiny dust grains to massive comets and asteroids. Most follow stable paths, but gravitational nudges from planets and distant stars can slowly shift orbits. Over large timescales, dense regions of debris, perhaps left by ancient breakups, may intersect Earth's path in recurring patterns. Some researchers propose that as the solar system moves up and down through the galaxy's thin disk, it occasionally passes through regions with higher concentrations of material or stronger tidal forces, potentially increasing the rate at which comets are nudged inward. Whether or not such grand cycles prove responsible for specific events, the geological record is clear that large impacts have struck Earth many times, carving craters, triggering fires, and contributing to past mass extinctions. Taken together, orbital cycles, solar variability, magnetic wandering, and the shifting architecture of the debris fields form a complex, overlapping pattern of external pressures. Sometimes they align gently, producing long eras of relative calm. Sometimes they stack in more dangerous ways with cooler climates, weakened shields, and elevated impact probabilities overlapping in narrow windows of heightened risk. Human civilizations appearing only recently in this ongoing dance build their worlds without direct awareness of most of these deeper rhythms. Yet beneath human horizons, the planet moves through phases that can reshuffle boundary conditions for life and culture. If earlier cycles of civilization existed, they would have found themselves subject to the same cosmic environment, tested by the same alignments of star field and orbital geometry. Some may have risen during unusually stable intervals and fallen when the underlying patterns shifted toward greater volatility. Others might have been cut down by rare coincidences where a transitional magnetic field and a strong solar storm arrived in the same era, or where orbital conditions and debris distributions favored more frequent strikes. The present civilization stands at one more point in this moving pattern, surrounded by invisible fields and slow, almost imperceptible changes in the sky's deeper structure. From the quiet of night, these grand motions seem remote, yet they form the stage upon which every rise and reset of complex life and culture unfolds, setting limits and opening possibilities in cycles that care nothing for the brief confidence of any single age. In the present age, the planet carries a civilization that wraps itself around the globe in a continuous web of roads, cables, satellites, and shared symbols. Cities shine at night like constellations, their lights linked by invisible streams of data. Oceans, once barriers, now function as corridors for ships and signals binding continents into a single intricate system. From a distance, this network looks robust, a tapestry of trade, communication, and technology that no local storm or conflict seems able to destroy. Yet beneath its brightness, the same pattern seen in earlier cycles appears again: rising complexity, growing interdependence, and a narrowing margin for error. Food flows from highly specialized agricultural zones to distant megacities. Energy grids knit entire regions together so that a failure in one place can ripple outward. Medical systems rely on long supply chains and precise coordination. Digital networks move information at light speed, but also concentrate critical functions in data centers and communication hubs that few fully understand. This delicately balanced arrangement has many strengths. It allows rapid response to some threats, the swift sharing of scientific insight, and the pooling of resources on unprecedented scales. At the same time, it creates new kinds of fragility. A handful of key components, if disrupted, can stall or fracture systems that millions depend upon. Historical collapses often unfolded over decades or centuries, their causes spread across climate shifts, political failures, and external pressures. In contrast, certain modern vulnerabilities can manifest in hours or days. A major geomagnetic storm interacting with long power lines and transformers could damage equipment across continents. A severe volcanic eruption could inject enough material into the stratosphere to dim sunlight, cooling the surface and disrupting rainfall for several years, just as global agriculture functions near the limits of arable land and water. A pandemic with high lethality and efficient transmission could strain medical capacities and ripple through economies that assume constant movement of people and goods. In each case, the very speed and integration that make the modern world so capable also allow shocks to propagate widely before local buffers have time to respond. Another layer of fragility arises from the way knowledge is stored. In many earlier ages, memories, techniques, and records lived in minds on stone or on durable parchment. Today, a vast share of technical and cultural information resides in magnetic domains and electronic states within devices that require stable electricity and careful maintenance. Libraries still exist on paper, yet much material appears only in digital form on servers that are updated, replaced, and sometimes discarded at a rapid pace. If large regions were to lose power for extended periods, or if key digital infrastructures failed in a coordinated way, many records could become inaccessible at once. Even if bits remained intact on physical drives, the tools required to read them might be scarce or non-functional. Modern civilization also concentrates critical production capacity. A small number of facilities manufacture certain essential components, from advanced microchips to specific pharmaceuticals. Disruption at these sites, whether through natural disaster, conflict, or economic failure, can cascade into shortages that affect distant industries and services. This concentration resembles the dependence of past empires on a limited set of fertile river valleys or mining districts, but with even tighter coupling and shorter feedback loops. At the same time, the planet's climate is shifting under the combined influence of natural cycles and human activity. Greenhouse gases accumulate, altering temperature and precipitation patterns. Ice masses retreat, seas creep higher along coasts, and weather becomes more energetic in many regions. These changes interact with existing vulnerabilities, placing additional stress on food production, freshwater supplies, and coastal settlements. Infrastructure built for one climate regime must suddenly function in another. In historical perspective, the current surge of complexity and resource use resembles the steep climb before a crest. Energy extracted from dense fossil deposits powers rapid growth, but the reserves that support this expansion are finite, and their use modifies the very atmosphere upon which future stability depends. Meanwhile, social and political systems strain to manage global-scale issues with frameworks originally designed for much smaller, slower-moving communities. The same communication networks that spread knowledge also amplify fear, misinformation, and conflict. In this environment, the risk is not solely a single overwhelming blow from outside, such as an impact or supereruption, but the possibility of many smaller shocks that interact. Regional droughts, economic downturns, cyber attacks, and local conflicts can combine into global turbulence. If enough critical thresholds are crossed at once, the system may tip from a state of high coordination into a patchwork of fragmented, less connected regions. In such a scenario, the material remnants of the present world would remain, but the capacity to operate and maintain them could diminish sharply. Satellites might still circle overhead without ground stations to command them. Chemical plants, refineries, and factories might stand idle for lack of spare parts or expertise. Data archives might sit unreadable in darkened buildings. From the vantage point of some future age, evidence of this cycle's achievements would be visible in durable structures, scattered machines, and geological layers enriched with unusual materials, while the underlying continuity of knowledge might appear as broken as it does when archaeologists today peer back at the ruins of past empires. The current civilization thus walks a narrow ridge between remarkable capability and significant fragility, carrying tools that could help anticipate and mitigate resets, but also carrying internal tensions that, if left unresolved, may hasten the next descent. If resets are woven into the long fabric of planetary history, the central question for any age is whether it must simply repeat the pattern or can learn to bend it. Civilizations of the past, to the extent they can be glimpsed through ruins and stories, appear to have risen, concentrated their power and knowledge, and then allowed that concentration to become a single point of failure. Temples, palaces, archives, and elite lineages served as both engines and bottlenecks. When they were struck by disaster, invasion, or internal breakdown, vast swaths of accumulated understanding went down with them. The present cycle has inherited this tendency, enhancing it with global technologies that link distant regions into a single intricate system. Yet it also holds tools for dispersion, redundancy, and foresight that earlier ages lacked. Learning to live beyond the reset would mean using those tools to redesign not only machines and infrastructures, but patterns of culture and memory. One path toward resilience lies in scattering vital knowledge across many locations and media. Instead of assuming that digital storage in a few centers will endure indefinitely, records could be mirrored on multiple continents, kept in both electronic and physical forms, and encoded in ways that remain legible even if specific languages or devices disappear. Simple, robust descriptions of essential practices such as clean water provision, basic medicine, food cultivation, and structural engineering could be stored in forms that do not depend on constant power, perhaps etched in durable materials, and archived in both public and hidden repositories. Another path involves designing systems that fail gently rather than catastrophically. Networks of energy, food, and information can be arranged so that local segments can operate independently when needed, maintaining partial function instead of collapsing outright if global coordination falters. Cities can be built with layers of backup, combining advanced technologies with simpler low-energy methods that can take over when supply chains are disrupted. Such redesign does not eliminate risk, but it turns sharp edges into slopes, making declines slower and more recoverable instead of abrupt. Education, too, can be shaped with cycles in mind. When learning focuses only on highly specialized tasks within stable institutions, it produces expertise that works brilliantly in normal times, but may disintegrate when those institutions fail. When some portion of teaching preserves fundamentals of observation, adaptation, and low-tech survival alongside advanced knowledge, societies carry a wider range of skills into any crisis. In this vision, certain roles resemble the ancient memory keepers, but updated for a world that understands deep time and planetary hazards. Individuals and communities could take on stewardship of key sciences, crafts, and narratives, practicing and transmitting them in ways that do not depend entirely on fragile infrastructures. Collective drills and local experiments in self-sufficiency could serve as rehearsal for larger shocks, embedding resilience into ordinary life, rather than treating it as a rare emergency concern. On a larger scale, cultures can learn to treat stories of past collapses not as distant tragedies or moral parables alone, but as practical case studies in systemic risk. The tale of a city buried by ash, a library burned by zeal, or a kingdom undone by drought becomes a lens through which to examine current choices. Institutions might simulate failures, test backup plans, and deliberately expose weak links before nature or chance does so without warning. None of these measures guarantee escape from all resets. Supervolcanoes may still erupt, impacts may still occur, and climate may still swing in ways that challenge even the most far-sighted civilization. The aim is more modest yet profound to ensure that when disruptions come, they do not erase everything. A society that has scattered its archives, diversified its food systems, decentralized its energy, and trained its members in flexible thinking may bend deeply without breaking entirely. In such a case, the next cycle would not begin from near zero, but from a plateau where key insights and tools survive. Over many iterations, this approach could change the character of the grand pattern itself, turning violent oscillations into smaller, more manageable waves. There is also a quieter dimension to living beyond the reset, one that concerns how a civilization understands its place in time. If a culture sees itself as the inevitable pinnacle of a single upward climb, it may be careless, assuming that whatever is lost can always be rebuilt in the same form. If instead it views itself as one careful experiment among many, standing atop a stack of partial memories and buried achievements, it may act with more humility, building not only for immediate comfort but for the benefit of unknown successors. Monuments in such a world might be designed less to glorify rulers and more to serve as beacons of basic knowledge robust against erosion and misunderstanding. Rituals might commemorate not only victories but also past recoveries, honoring those who rebuilt after disaster as models for future behavior. In the end, the possibility of living beyond the reset does not erase the mystery or danger that surrounds civilization. It offers a different way of engaging with them as a participant that accepts the larger cycles, yet works to carry a thread of continuity through each turn. Against the backdrop of Earth's restless geology and shifting cosmic environment, that thread may be the closest thing to permanence that any intelligent species can weave, a slender line of memory stretching from one age of light to the next.